pathology area. I will share my slide. Wait a moment, please. Okay, and then show all window. As everyone can see my slide.
Yes, yes.
Okay, thank you. Let me wait. Okay. Yeah. Okay. First of all, I want to give you the outline of my talk this morning. I will describe what I meant about the computer-aided pathology, or in publicly term that currently used is digital pathology. So these words are interchangeable. And then I want to highlight the advantages supposing we have that such system. And then we will look what is the workflow for that, and then what is the Indonesian challenge on this area. And then after that, I will present our experience on doing this developing this computer-aided pathology in the application on the pap smear, HER2, tuberculosis, and then malaria. And then toward the end, I will highlight the future work that we aim to do. So what is the computer-aided pathology? The computer-aided pathology will incorporate the acquisition, management, sharing, and interpretation of pathology information, which including slide and data in a digital environment. So if you remember, maybe in your senior high school, the biology teacher asks you to read the glass slide of biological substance. So
sorry,
maybe
Dr. Izzati, you may please share the the slide view. You share only in the PowerPoint.
wait.
Please.
Oh, wait. Now it's correct?
No. Yeah, now correct. Okay.
Okay,
okay, nice.
Because in my screen it's correct. Thank you for the information. I will repeat on my explanation. So this work is related to the job that pathologists do. They usually do the glass slide reading of the biological substance. Yeah, and we may have that experience when we are in the junior high, that our biology teacher asks us to see the slide under the microscope observation. So the tools arrangement may be like this. So in this area there will be the slide, and then there is like that usually we see that from the ocular optic here, and then on the top of that there are some microscope that have the couple camera that CCD camera that couple in this microscope, and from that we can see what is been seen here through the computer. Okay, that's the setup of the device. And once we have that digital version of the glass slide images, then it can be captured and then scanned, and to have the high resolution digital image that can be viewed on the computer screen. That's what the area that we want to explore in this artificial intelligence application. Okay. And then what is the advantages of having this computer aided pathology? As we know, the microscopic reading is a very advanced knowledge. It's back in the time about 100 years ago that people relate the cause of the disease by the microbe, and then it can be seen by the microscope. The knowledge has advanced, it have a long tradition, but now the time asks us to have that in the digital archiving, because when the information is the I will jump to this workflow. Okay, I jump to this. Yeah, usually we have like this. Yeah, we have the slide that is stained and then a cover sheet, and then we will read that under the microscope. And then before a pathologist can have the reading under her or his microscope, this process needs to be labeled to have the quality check of the quality of the stain, and then transporting to the pathologist. This workflow is also still remain in Indonesia in that way. So in the current practice, in Indonesia is not yet ready with the digital pathology, but so we are working on that to develop the system for the digital pathology. If we have only the slide, there are some drawbacks. Yeah, because the color may ruin may be ruined over time. And then for several time, several 1 year maybe, when we read that, we cannot see the cell clearly as when it is set. That's the drawback of the slide. And saving the slide have the specific requirement in terms of the room temperature and the in the room temperature and the way to handle the slide. Okay, when it is need to be discussed among the pathologists, if there are some difficult cases, for example, the slide need to be transported to the pathologist. So for example, like this, in Indonesia, every year there is like pap smear reading. That's the program by the government. But the pathologists are scarce, is limited in the big city in Indonesia. If you can imagine, Indonesia is very wide country, and then it many has islands. So transporting the one slide is not easy. So having a patient that need to be checked to see what is the diagnosis that correctly for her or for him is takes some time, because the slide need to be transported. Okay, but having the digital archiving by scanning the slide it will be instant access for the multiple location by multiple people to to diagnosis that images. And then there is no searching for slide, because when it put in the box, although you arrange that in a certain way, when you want to review that, you need to search which slide in which row, in which column that the image, and we have to check the correct label. So it's not easily directly access to the image. And then having that once the image is captured in the good quality, is constant quality, not deteriorated over times. Then it have potential for doing the telepathology, which is the consultation, revision, and panel, which the expert are in different island or different city. And then it will serve the education. So the student will be happy if they know the image they see is very high quality, not the one that deteriorated. So it make they very stressful in learning the digital pathology. And then when it has a digital format, it will be many research activity that we can done in terms of the informatics approach on that data. As I mentioned, is also will go to the automated image processing research. Here are some overview of the improvement of the quality if we have the glass slide digitized. It will improve the analysis because we can apply algorithm for analyzing slide objective, accurate, and quicker than the observation under the microscope only. I will give the illustration later when we came to the cases. Then when we have that the digital version, it will be have the rapid access to the prior cases, so we can have the pattern over time. When we have only the glass side, it will be problematic. Yeah. When we have that, the data storage also allow us for long-term predictive analytics, because the data is there and we can review that timely. And then in terms of the reduced error, it eliminates breakage, and when the barcoding is easy to read, it reduces the risk of misidentification. And then with the digital pathology, we can have better view. We can zoom the image, or we can see that the image from a different angle. And then we can also have the ability to measure multiple area. And we also can have the tool for annotation. And we can also build the dashboard so to view several data and annotation. Some diagnosis need that the image that need to evaluate is more than one. So for example, for the tuberculosis cases, we need for one patient to have 100 image to be reviewed. This in the term of quality. And then there are other aspects in the term of productivity. With the digital pathology, we can improve the workflow because it fosters collaboration, and there are central storage that enable easy access of the streamlined workflow. And then it can allow for automation, flexible working schedule, and the remote access. That will also suitable in this time, in the time of pandemic. Then we need to work from home. That's possible if we can do the system is digitally. And then it reduces the turnaround time because faster access to archive digital slides. So if we want to do comparison with the past data, it's easy to do. And then reduce the time retrieving data, matching and organizing, speed up access to sample, and improve turnaround time versus manual review, especially in complex cases. this what it means. Sometimes the quality of staining is not that good. So in that case, the pathology may not may not decide what level of the cell or what stage of the cell. So the pathologist will ask the laboratory to make the new sample of that patient. That will happen if we use the manual glass reading, and then that process will take time, and then it need to transport it. It will be take some more time. But if we know that we need to retake the new sample, when it is digital, it will by the email, and then in the laboratorium prepare the new slide, and then freshly stain, and then scan, then send by email. No need to have the slide transported. That's the idea. That will reduce the turnaround time. And then with the new technology in terms of productivity can be achieved by the allow to have the more innovation for the data. So like implementing the big data algorithm. So the pathologists may look to the information on the given slide in the specialties, and then allow the practice to extend to broader geographies, and then deliver better tool for teaching and training. That's the improvement of computer-aided pathology in the workflow of the pathology process. But now we also can see the advantage in terms of the benefit to the patient, which is the computer-aided pathology can support precision medicine. What does it mean? It means that using that the digital images of the pathology cell, we can use the statistical analysis and machine learning to link with the data. And then we will have integrated analysis of the data. And then after that, the image analysis and deep learning can be done to extract the feature from the image, and then it can support query again, assemble of feature extracted from multiple data set, and then identify the segment relevant of object, which is whether it's nuclei, gland, duct, nodule, or tumor. Then analysis of the integrated spatially map can gain insight into cancer mechanism or to choose best intervention. Our experience on this targeted medicine is related to the breast cancer cell reading. Having that reading correctly, it will help the doctor to recommend the best medicine that suits to the patient. That's what it means by the precision of medicine. Okay. And here is the history of the workflow. In the early step of pathology, computer-aided classification is like we analyze image by computer, analyze the whole tissue, several slides, provide quantitative information to the pathologist, and reduce intra and intra-reader variability. Yeah, this is a common thing that happens when we do the slide reading. Yeah. My current research is on this stage, in the early step for pathology computer-aided classification. Even though I have experience in many areas of disease which have different image manifestation, but we we are working toward the workflow, which allow the computer system will help the laboratory worker and the pathologists to have the reading of the slide. Here is the picture. Here is the idea of ontology for a given image. So if we have the image here, and then we can measure the feature of the image and then put that into what concept of the ontology. From that, we can see whether a given image is a part of what classification, whether it's a neuroblastoma or ganglioneuroblastoma or ganglion neuroma. So this is what the aim of computer-aided classification of the pathology images. This is the illustration of the workflow that usually done in the manual slide reading. So there is a patient that need to be take their sample, and then the laboratory woman or man will create the stain and the histology for the glass slide, and then the information need to be labeled, giving the barcode to give the information about the name of patient, the stain that used, and that what of part of the cell that it is taken, and then after that it transport to the pathologies. In the term of primary care, transport can be just moving to other desk in one room. Then the pathologist or the laboratory works will read the slide under the microscope. That's the workflow in the manual microscopic reading. Yeah, in the digital workflow, in the standalone imaging solution, the process here is not transport but scan. Before that, it need to be have the registration. In here is named, the process is case entry, and then the imaging is the using the scan or the reading by the CCD camera. And then after that, the case assembly, and then quality check, and then read by the pathologist via the computer screen. That's the idea. Many pathologists in Indonesia really hope that this setting will become to their clinical practice, because reading under the microscope is very tiring. You can imagine that when there is like a scanning period, say like for pap smear reading, the pathologists have to read about 500 slides a day. So 500 patients that the slide need to be read in a day. So that's very tiring, but you have to focus to read the cell under the microscope. Okay. We on that this workflow we see the green one is the equivalent task from the previous manual setting. The case entry is a duplicate task, and then the scanning is the new task. And then this, because duplicate can be eliminate when you scan the slide in the several certain order. You don't need to sort image to cases, so this process can be eliminated. So then the workflow will be simple. Once the case entry, preparing the glass slide, and then do the imaging, and then quality check of the slide, or review the image quality or review the test quality, and then send digitally to the pathologists. This workflow done by the laboratory worker and then read by the pathologist. Okay, that's the workflow that I shown is already put into practice in the UK, in the Europe, and in the States. But in Indonesia, that system is not yet widely adopted. It may adopt it in certain hospital, big hospital, but not in the public primary care. Yeah, in Indonesian case, there are some challenges that we face. Firstly, it is pathology data serve as the main standard in all cancer disease diagnosis. In other words, there are some examinations. So for the cancer disease diagnosis, there are some examinations. So I give the illustration for breast cancer. Yeah, to know whether the woman or the man have the breast cancer disease, they may go to the GP, and then the DGP may then refer to the radiologist, and then the radiologist may ask you to undergo like ultrasound examination to check whether there is like symptom of breast cancer. If that not sufficient with the ultrasound reading, the doctor may ask you to do the mammography. However, there are two modalities in the breast cancer diagnosis is not sufficient. The post ultrasound and the mammography may tell you that you have some mass on your breast, maybe something like that. But whether this mass is benign or malignant, this another step to do, which is the pathologists will do. So the laboratory worker will do the fine needle biopsy in that the area that you say that I'm so painful on my breast, like that, and then from that they have the cell put that on the slide, and then the pathology will decide whether it's benign or malignant. So this will be the main standard in all cancer disease diagnosis in Indonesia for all kind of cancer. So the pathologists are the busiest person in reading the many slides in one day. And then unfortunately in Indonesia, there are limited number of pathologists. In about information in 2000 and in the year of 2010 is only 200,000 pathologists to serve about 250 million population. So the number is very short. Is it can be understandable that reading the pathology takes some time in Indonesia. My friend has the wife have the cancer, and he told me that the time to wait the diagnosis is about 10 days because a long queue in processing that data. That's still the problem or the challenge that happen in Indonesia. And then when we have the manual reading, we cannot avoid the subjective assessment. And then we usually, when we test that or validate the reading, there are some conflicting result among the pathologies or in one pathologist, what it means. So if we have one slide, say 100 slide, and we ask the pathologist to read that in one time. So when he or she decide the grade of the cell in the time, we have that information. And then we let her pause to see that in, say, 3 weeks. And then in 3 weeks later, we ask her to read the same slide again. And then in that second reading, the assessment, which is subjective, may differ than the previous assessment. That we call that intra-observer reproducibility. And in that case, we cannot find 100% reproducible. It's impossible. Yeah, that's among one person. If we have one group of pathologies, say we have 3 pathologies, yeah, they may have different opinion on one slide. So we ask the pathologist A to read, and then pathologist B consecutively to read in the different day, and then another day is the pathologist C. We can see there are some discrepancy on the assessment they wrote on the report. So in that situation, we can find that the inter-observer reproducibility also poor. Yeah. Okay. In Indonesia, the computer-aided pathology is not yet there as a system in the clinical practice, but the requests are there. So the laboratory and the pathologists have approached us to develop such system to help their work. Okay. And we can see that the potential in combination of digital pathology and machine learning and AI, it will make possible adoption of image data driven decision support system. We cannot stop this technology to help the work. And some study show that the image data driven decision support system is outperform that manual reading, and it can outperform the inter-observer reproducibility. Yeah, having adoption of subsystem will have tremendous impact on improving quality and consistency of clinical decision making. So if we have very high confidence level on this system, the targeted therapy then can be done. Next, I want to show our previous work on this clinical pathology. First, we will review our previous work back in the 2013. This is maybe I will check whether Pak Ian has joined this meeting or not yet. This research is our collaborative research, me and Pak Rahadian Kurniawan, which is when he was the master program in informatics student, and then Dr. Indrayanti. She is the pathologist. She challenged us to have to build the software to help her to count the cell. So our first task is the in this clinical pathology area is only counting the cell. It looks easy because we only count the cell. If we know the concept of a cell, is a cell have one nucleus and then have surrounding cytoplasm. Okay, the idea is simple, that if we can locate the nuclei, then we can simplify the task of counting the cell. Why we need to count the cell in the pap smear images data? Because counting the number of the cell is one of the quality assurance before the data can be reviewed for diagnosis. There is some requirement that in one slide there exists 4 types of cells. So the 4 types of cell must be there. If the cell is not there, they say the glass slide cannot be reviewed. So it's not good enough to give the information to the pathologist to review the image data. So that's the idea. So we have to classify the cell. Before that, we have to count, because in every group of the cell there are certain number of quantity of the cell that need to be checked to do the quality assurance. Yeah. But the challenge is like this. These beautiful images are not from Indonesia. It is from the liquid base preparation, which is not used in the clinical practice in Indonesia. But we learn from that, from this image, from the database of pap smear, and then from that we want to model the computer-based system to know the cells, so that we can count how many cells other. Okay, that's the first idea. To achieve the aim to detect the cancer cell, we then targeted the nuclei. Okay, we combine intensity, SEP analysis, and the fuzzy semen to detect the nuclei. And then after that, we will check, after we know the nuclei, we will check the surrounding cytoplasm. If there is the cytoplasm is in the closed loop, and then it will be a normal cell. But if there is no cytoplasm under that area, it will be inflammatory cell. So the cell that are broken. That's our research question on this. Okay. To do so, we do like this. So this is the example of one of the image. We have in A here is the initial image, and then here we have some normal epithelial cell and then some inflammatory cell. As I mentioned earlier, the epithelial cell will have a nuclei and it's surrounded by the cytoplasm, which color here is the light blue. Okay, and the nuclei is the darker color here. But these cells are not epithelial because the cytoplasm has broken. So this will be categorized as the inflammatory cell. Okay. To do that classification, we firstly identify the potential nuclei candidate. We select the object which has the darker color. So then we can see in the figure B here, the darker color is mapped automatically to highlight that the darker area. And then having that darker area, then we choose the centroid because we need to count, so we reduce the data. So the plausible idea to reduce that by finding the center of the data. So we put we find the centroid of the darker area, and then having that area and that center, we evaluate that in terms of color, shape, and then texture, and then put that in the fuzzy semin classification. Okay, so from that we can have this label. Okay, and then from this fuzzy, we check whether it's surrounding by the cytoplasm or not in the fuzzy semin. We then can have that two classes, which is the it is nuclei and then not nuclei. So we divide this data into two classes, which is nuclei or not nuclei. And then from that, we can, having that divide into two classes, we can have the information which is here is this is so not nuclei, and this is nuclei. So the not nuclei will be labeled as the inflammatory cluster. That's the first tackle to see the number of cells, how many how many cells that are epithelial and how many are that are inflammatory. And then further, we want to investigate, because in the data there are some overlapping nuclei. We have to count the cell, but when you do staining, the individual cell may overlap each other. So we need to have that cell count correctly. We need to separate the nuclei, and we propose to do so with the watershed transformation in combination with the shape analysis. And we observe that from the pap smear data, the shape of the nuclei are elliptical. So we combine the watershed and elliptical approach to separate the overlapping cell. Okay, the image that in the column A is the initial image, and then in the middle, the B is the separation of the nuclei using only watershed. If you see that in the watershed there are two centroids, and then they will attract the data. But if we check, then they have the border are not elliptical as the concept of nuclei should be elliptical. To do correction, we then model from the new centroid, we model the elliptical border using the shape analysis. From that, we can then make, this the nuclei 1, nuclei 2, and we see the area of overlapping cell. Okay, the detail of the methodology can be, an algorithm can be seen in our published journal. That the title I put that on the slide. That's example of the pap smear that we have done, and we also have the experience on the breast cancer assessment. This cases is different approach, because in the breast cancer assessment, which lead to the targeted therapy, we need to measure the border, not the nuclei, but the border of the image. We want to know whether the brown color here, is already joined or broken. So the challenge is focused on the border of cell or on the cytoplasm, and we process the image that has been stained by the immunohistochemistry approach. There are some stain on that, and then that the normalization, some are clear, some are not, the brown color on the border, and then we also need to do the pre-processing. To do the pre-processing, we have investigate that we can use the color swapping to enhance breast cancer digital image. This idea we learn from Mr. Nasir Rajput of Warwick. And then having that pre-process, then we identify the appearance of the stain color, whether it have the positive one 2+ or 3+. So actually, this investigation lead to several thesis project. So we done for the positive one. It means that in the early stage of breast cancer, and then the second one is in the borderline, and then in the 3+ is the there are manifestation of the risk of breast cancer. If the patient has the 3+, it will go to the medication straightforward. If they say the image is 1+, is this it is not on risk. In the 2+, if not sure whether it's on risk or not on risk, usually the doctor will ask the patient to go to other process, to other tests, to make sure whether they can take the medication. Because if they're actually not 3+, the patient say got the medication, the body cannot absorb the medicine. That's the problem of having the identification of this test is crucial, because it gives the patient the correct medicine should be taken. If 3+, you go to the treatment A. If you not 3+, and then I got the medicine A, it not work to cure the breast cancer. So that's we want to make sure whether it's 2+ or 3+. So we also doing that research, and the system help to do the targeted therapy. In the other cases that we also investigate is related to the malaria assessment. I see one of the participants doing this research. I see Nani. Hello, Nani. I saw your work here. Yeah. We do the research in malaria assessment, specifically on the Plasmodium falciparum staging. So there are staging of the formation of the blood cell, which is a tropozoid, season, or gametosis. This the manifestation how severe your blood are infected by the Plasmodium falciparum. And then we develop that tool based on the color of the infected area and the shape of the stage of the Plasmodium. Currently, we also investigate two other type of Plasmodium, which is oval and is currently done. Falciparum, oval. I don't remember what is the name. There are 3 types that we investigate, but we've done with the falciparum, and it's published in ICASI in India. So that's the idea. So we have the tools to read the image, and then after that we select the object and the candidate of the abnormality and evaluate the abnormality with the given criteria, and then count how many which is tropozoid stage, season, or gametosis. This is the idea. Okay. Okay. The current project that we done is the publication is still in press, so we haven't we cannot put the publication about that, but we've been asked to identify the microbacteria of tuberculosis. Yeah, this image is different with the previous one. From the sputum is when we cough, a heavy cough, the patient needs to be cough and then coughing. Then the sputum is give the coloring and then put that under microscope. This sputum is colored by the Zell-Nielsen, and then it looks blue. If there is like a microbacterium of tuberculosis, it will have the red color. Finding red on blue is not that easy, so that we develop some algorithm to know that, and we ask the radiologists to know the pathologists to do the manual annotation, and we compare and learn from the annotation in terms of its feature, and then we go for this using not only color but also using the texture to define the microbacteria of tuberculosis. That's the experience that we do to develop the system for computer aided pathology. Okay, so this is toward the end. Am I all right, Pak Ivin, or I'm too quickly?
You
I'm
have
all right, yes.
yes.
Yeah.
You still have almost 5 minutes lah.
Yeah, so I'm in good timing. So for next, we want to investigate more on the clinical decision support for the tropical disease. So in Indonesia, there are some cases of leptospirosis. This is faced by the farmer, and it caused by the ferment. So we want to address that issue, and also there are some requests that we also make the tools to help the laboratory worker to do the urine analysis, and then other thing that may ask to develop the algorithm. And then we know nowadays the work is mostly done remotely, so we may think to develop the computer aided pathology on mobile device. That's the other thing that we try to look forward to. And then we also want to develop the integrated analysis system that incorporate the pathology reading with the molecular or MRI or clinical lab results. So we want to have the integrated analysis with other modality to define diagnosis. And then we also want to develop the system for teleconsultation of the pathology images, because this is also still have problem, because the limited number of pathologists that are available in Indonesia, and the consultation sending the slide island will be very high risk and then take some time. So we cannot avoid the digital pathology workflow. Okay, that's what I can present for now. And then thank you.
Okay.
I'm ready for question then.
Thank you, Dr. Izzati, for your interesting question presentation on computer-aided pathology. Now I open the slot for Q&A. Let me read the question from the participant.
Yeah.
Okay. I think first we go for, okay. This is a bit technical from Abdul Aziz Muhammad. He wants to know if there's a problem with, okay, if we talk about images to support pathology, there must be an issue with the camera and so on. How to deal with that?
Oh, so the participant asked me about the setting up of the acquisition process. Yes.
Yeah, I think so. Something like that.
Okay. We in practice here in Indonesia, we haven't have the integrated system in the imaging task. In other part of the globe, there are some system that developed by other vendor. About 4 player on developing such system. But in Indonesia, mostly in the primary care, the government only provide the microscope is the Olympus TX, the device that already done there. So we to do this experiment, we put the CCD camera that high resolution as possible, and that mounted to that microscope that available to the laboratory. So, but I not remember Pak even what is the brand of the CCD camera, but
Okay.
we find the one that match with the connector is matched with the microscope that there in the primary care.
I see.
Yeah.
So you mean it should be an integrated imaging devices should be. Okay. It
But
should be.
the imaging devices that can have the many slides, put that in that system and then scan automatically is not available in Indonesia.
Okay.
So we propose to mounting the CCD camera on the microscope that available and used in the primary care.
I see. Okay.
Yeah.
Okay. Next question. I think we have another question. This one is from Rohana. I think it's a Miss Rohana. She asked about the rule in Indonesia. Does each hospital or institution need to build their own retrieval image system or any standardized data center for this kind of pathology diagnosis?
Okay. In developing such system, we have close collaboration with the Ministry of Health, but in the level of city. Dinkes kabupaten.
I see.
Yeah, so so we approach the district of Ministry of Health. We, in our case, we have close collaboration with the area Sleman, with the university reside, and then we also have the collaboration in the Central Java Temanggung area. Then from that we set up the focus group discussion about the user requirement of such system, particularly in the tuberculosis cases reading. Yeah, and then in Indonesia, this tuberculosis reading is the national program. So the government put some money in setting up the having the slide if the patient have the symptom. So if the patient coughing for 3 days, it must go to the primary care and then have the glass slide prepared to investigate. And the quality check for that slide is controlled by Balitbangkes. I don't know what that in English. Balai Penelitian dan Pengembangan Kesehatan. So like
a research center.
They have like the government body to control the quality of the laboratory works. Okay, so this body is every year do the validation of the intra-observer of the laboratory worker. So every year, nationally, they have the time to ask the laboratory worker to send their reading.
I see.
And to send their slide to this government body. And then a person in the government body will check whether the assessment by the laboratory worker on that TB are correct.
I see.
If there is like one misreading,
I see.
The gentleman or the lady is tell off by this government body. So this government body is have the quality assurance on that slide, glass slide preparation on tuberculosis. Okay.
I see.
In terms of the data, whether it's already digitized, the answer is no.
I see.
Because the slide and the assessment that transport to the government body, and then in the government body is still read manually under microscope. So if you ask whether there is such digitized pathology in this TB, I say there is none yet. That maybe some scan, but not access in public yet. That's in Indonesia case. But if we look the data in international outside, there are some pathology database available. So if you are computer scientist that want to check the algorithm, you can use that. But in the Indonesian case, I haven't seen that ready for the database images assessment. That's the situation.
I mean, looking at the challenges and probably obstacles to implement this kind of pathology, do you think having a big data is a bit long way to go for Indonesia?
I don't think that will be long way because the demands are there. In our TB that I haven't mentioned it here is actually one patient need to evaluate on 100 images. So from one glass slide, it need to be reproduced into 100 images. That is like full view of the microscope, but you slightly move the slide. So you take the picture of one and you move slightly to take picture of the second image across that. So if like this, if I will draw some, I will draw what I meant. Yeah, here. So if you look here in the under microscope, you may take that one. Okay.
Okay.
Yeah, because it's enlarged, maybe 40 times or 20 times. So from one view, you only take this as a data, and then you need to move your slide so you can have that area. You can have that area, and you then will have that area. You move your slide so you can have 100 picture of that.
I see.
That's impossible to do without overlapping view manually.
I see.
That's the demand they ask. That's why we develop robot to take this this picture automatically. It's still working and done by Agus Darmawan now. Yeah, having that, maybe it will be soon. There is database for the data science for one tuberculosis cases. We are working on that, Mr. Ifring.
Okay. Quite interesting, but I think we the time is up for our first session. Thank you, Dr. Izzati, for your presentation and also for your answer. So you want to close or something or for your session?
Yeah. Thank you everyone for having me here, and we hope that this presentation give the idea about what that we need to be done in the area of computer aided pathology, and then I hope that I also show you the potential for the future work that we need to be done. So I'm happy if one of you maybe can collaborate with us to make this such system available to help the pathologists make the correct decision based on the slide reading. That's all.
Okay, thank you. I think we go to the next speaker. We have here Professor Hans.
Yes, I'm here.
Okay.
Can you hear me?
Yes, I can hear you very clear. 안녕하세요, Professor.
안녕하세요.
What's your name?
So my name is Hansung. Just call me Hans.
Okay. Professor Hans is. Can I introduce about yourself first?
Okay. My name is yeah.
Okay. No, I mean, let me introduce you.
Okay, your
Let
turn.
me.
Yeah, okay, thank you.
Professor Hans is an assistant professor in Youngsan University. He is also a director of AI Convergence Research Center, if I'm not
Yes.
mistaken, since January this year. And he was a principal engineer in Samsung Electronics for about 5 years, if I'm not mistaken. Professor Hans received his PhD from Korea University, and his expertise is in the area of machine learning, data mining, pattern recognition, and computer vision. So many publications have been done on that area. I think he's now into deep learning. Based on his curriculum vitae, I saw that he's now working on like deep learning based object detection with video from drone, if I'm mistaken. And I think this kind of object detection using drone is quite emerging. Okay, Prof, please, you may now start your session.
Okay, thank you, Mr. Chairman.
Mm.
Yeah, so I will start my presentations. Can I share my?
Yes, of course, you.
Yeah, okay. Can you see my presentation?
Yes, very clear.
Okay. Now, the slide or some control panel. Do you see the slide?
Yes.
Okay. Let me start.
Yes. Yes.
Okay. Hello. Good morning. Today I will talk about the object class detections based on the deep learning. It's a little bit the complicated subject and the computer vision. My talk is consists of the four parts. First one is the introduction, so the second one is the picture extraction and the picture running. And the design is, finally, I will introduce the sample application. As far as I know, most of the audience is undergraduate students, so I will briefly introduce the definition of the object recognition problem. The object recognition problem is the task for the recognizing the object instead of image itself. So object recognition is briefly divided into three categories: the object instance recognitions, object class recognitions, object class detection. The object instance recognition is identifying the object instance. For example, you can apply the object instance recognitions for the crime suspect detection. So you can identify same people, the crime suspect, across the several surveillance video. That is the application of object instance recognitions. Object class recognition is just the classified object as just the predefined class. But object class detections determine whether or not any instance of categories of interest are present in an input image. So we need to locate the specific location of the object. That is the difference, the object detection from the others, the definition. To object detect, we use several technique, and we need to know the object detections of the class. So we just define object categorizations, object class detection, and the figure ground segmentation and the semantic segmentations. The object categorization is just categorize the object inside the image. So when you input the image, we just output the category of the object inside the images. See these pictures. The input images, then the system output just the category of object inside the images, person and car. But object class detection, the output, the class or categories, and locate the specific object. Look like these images. You just find the person and cars. The segmentation is more complicated subject. That is a segment the outline of each object. When you apply this technique to the general case, then you can segment the object and slope and background, like the figure D. There is a difference terminologies: object categorization, object class detection, the foreground segmentation, and the semantic segmentation. In general, the object class detection consists of three parts. One is picture extraction, and the second one is the machine learning model, and the last one is applications. The picture extraction is the core step of object class detection. So we have a lot of the technique for getting the pictures from the images. So we can use grayscale images as color informations, gradient, textures, something like that. Most generally, the descriptor, that is how can we extract the pictures from the image. The descriptor is picture representations. The roughly divide the three categories: pixel level picture descriptions, patch level picture descriptions, region level picture description. The pixel level picture description is like the gray level pixels intensity or color histogram. That is not good for the counter vision. The patch level pictures descriptor is like that: the shift and its variant, the filter bank response. Recently, the shift and the filter bank response is widely used for the extracting pictures from the images. Last one is region level picture descriptions: backup pictures, the hook and variants, the gist pictures, shape pictures, something like that. But most of the promising approach is the backup pictures in the field of computer vision. So we focus on the filter bank response and the backup pictures. Next one, so before going to the deep learning approach, we don't need to examine the filter bank. Usually the picture engineering, I mean extracting pictures, conventionally we use the filter banks. The filter bank have several variations. Mostly widely used filter bank is GABA filter bank. As you can see, the filter bank, GABA filter banks look like the directional images. So the GABA filter bank consists of a real part and the magnetic part. Usually, we use a real part to detect the edge component or texture information from the images. You imagine that if you overlap this filter into the images, you masking this filter on the images, you can find the component of this direction and with this height. So you can find the component of look like this. That is used for the edge detections or the texture description extracting. The GABA filter bank is similar to the human visual system, but that is very difficult to understand how they work. Another is the filter bank, the RM filter bank, and the Schmidt filter bank, and the maximum response the filter bank. That is a variation over the Gaussian the functions, the first derivative or second derivative to make us this filter bank. So you can see the first layer of a convolutional neural network. Actually, the convolutional neural networks consist of some filters and the other operation. That is the trained some filters, and I mean the mask and the post convolutional layer. You can see my presentations. The trained filter is similar to the GABA filter bank or ML filter bank or something like that. Actually, the convolutional neural network is trained as the effective filters, but the trained filter is similar to the conventional filter bank. That is why convolutional neural net work well, because they have so many filters to extract the effective picture representation. If we use all of filter bank as we know, then we can make the system, the performance very similar to the convolutional neural network. Anyway, we need to compare the conventional approach and the neural net, convolutional neural net. Most promising way of the extracting pictures from the image is a bag of word. That bag of words consists of the middle level picture extraction technique and some how can consist of their pictures. The bag of word make the pictures using the part of the object instead of whole object. So you can the clustering the pictures itself as a component, then make some dictionary over the image. To extract the pictures, you can use shift picture, self picture, or past picture. That is important. How which the picture extractors is used for the bag of word. You just select one of the existing picture extraction method, such as the shift pictures, circle pictures, or press picture. The basic idea of bag of word is like that. You need to distinguish the human, the bicycle, and violin. Most people think that you can distinguish these three objects using the shape of face or the total shape of the bicycle or the head motion or the body of a violin. But according to the experiment, the distinguishing point is different from the human thing. So to distinguish the three objects, mostly the distinguishable picture point is like that. For humans, eye or nose, but to distinguish the bicycle, the chair is important part. And to violin, the hip of violin is important part of the computer vision to distinguish this kind of three objects. That is the concept of the bag of words. To compare the conventional approach, we need to examine this convolutional neural network. So the distinguish was identify the sports car and the dogs. We think that The shape of the car is important key point to distinguish or identify the car. But according to the experiment, the sports car is recognized by the wheel, and dog is the recognized by the head. You can see the attention map that is actively activated neuron inside this convolutional neural net. Similar to this backup words, the most distinguishable point of the object is wheel and head of dog. Is part of a whole object. That is the key point of our object detection using deep learning. Instead of the manually extract the picture, we just train this filter bank. So that is a strong point of a convolutional neural net. I mean the deep learning. To compare the strengths of the pictures from the convolutional neural net, I make some self-similarity matrix. This row and columns means the object, and if the picture is effective, then we can find the object class inside the self-similarity matrix. The first one, I make the self-similarity matrix using normalized RGB pictures. You can find any distinguishable or some separated object inside that matrix. That means the normalized picture extract the RGB picture is in this case useless. I mean it is not effective. So I applied the cover pictures. So I make the self-similarity matrix, but compared to the RGB pictures, the cover pictures find us the object class. The diagonal part is the same object class. So for example, 1 to 9 is the same class. The 9 to 8 is the same class, but you can't find any object class inside this self-similarity matrix. I use backup pictures using shift and pressed. Actually, this diagonal box is the same category, but the BOF with the shift detects the effective component of the class. I mean it can distinguish each object class, but it is not enough to apply to the object detection applications. The past is also not enough. The surf, the backup picture with the surf is better compared to the previous approach, but you can distinguish any categorical decision boundary. But surprisingly, I applied the picture extraction from the CNN, the 5th pooling layer and the 7th layer. In these pictures, I make the self-similarity matrix. The boundary of each object category is more clear than the conventional approach. So in this case, the picture extraction from the CNN, the 7th fully connected layer, you can see the boundary of each object class So this one is the categories, the second category, and the third, fourth, something like that. So when we use the pictures extracted from the CNN, then we can more effectively identify the object crash. So the object detection is roughly divided as two kind of the crashes. One is a class-specific object detection and the generic object detections. The class-specific object detection detect only one specific categories, such as pace detection. Pace detection is the detect only pace inside the picture, but the generic object detection is detect the multi-categorical object. For examples, the generic object detection can detect car, human, dog, other things inside the images. The generic object detections are roughly divided into the two categories, single object detections and multiple object detections. The single object detection is a silence-based approach. It detects only one object inside the pictures. But in the real world applications, we need to use multiple object detections. Multiple object detections detects the multiple object inside the pictures. That is very useful. For examples, you consider the autonomous driving. For autonomous driving, you need to detect the several and the several categories. For example, so you need to detect the lane of the road and the human, I mean the pedestrians and the sedans, trucks and buses, something like that. Even you needed to detect the boundary and buildings and trees on the street and the signboard, something like that. So when we say the object detection, then that is a multiple object detection in real world application. The multiple object detection and localization consists of this architecture in general. In input images, you need to find the object candidate. There's a generic object proposers, and using the input images, so you're generating bounding box and the pruning unnecessary bounding box and the object localized. To identify its bounding box, so you need to use some machine learning algorithm. So you just use some ensemble models, so picture extraction and image classifier. In generally, in convolutional neural network, we replace this part with the CNN. To generate the object region proposals, there are so many approaches, but most important thing is objectness. The objectness is to find the area that is suspected to include the object. But the speed of the application, the most of the algorithm skip this step. They just make a lot of the candidate to the bounding box and the classify that bounding box as some category of images. But to make it somewhat accurate and parse the object detection, from the perspective of localizations, then I think we need to apply some pruning or detecting the object candidate areas using objectness. That is a simple example of the pipeline for object detection. First of all, at first, you can find the bounding box that is suspect to it include the object inside that rectangle. So they propose several candidates, and then each bounding box is input to the machine learning algorithm. Then classifying or identifying this area. I think that is not contain the image of product, so that is reject or discarded. Then ultimately we can find the exact bounding box. I mean, so that include the real object inside of the image. That is the general pipeline for object detection. To design this object detectors, so we needed to consider the several side effects. The training the data, we needed to find some region and the resize and crop. Right, that's that in train these images, and there's a testing. I mean, the predicting for the stage. We needed to find some cropped images and the crop and the resize. Then compared to this one, that is a general the way of the object detection. But as you can see, the image crop for compare is distorted compared to the original image. So it might be the affect the performance of the object detection or image classification, something like that. So you needed to consider this side effect when you design the object detection algorithm. The issue is that your system find the proper bounding box and classifying this one, but it has a low competence. Then you can find the correct location, but the competence is low. Then you need to discard. Otherwise, you can misclassify or something like that. So you need to consider how to deal the low competence value. Last one. There is a way, and so you can propose several bounding box around the whale, and then classify each part of the image to the machine learning algorithm or deep learning algorithm. There are several bounding box that is classified as the whale, but there are so many bounding box around the whale. We needed to choose only one bounding box. How can we do? We use a non-maximal suppression. So we find one of the bounding box that has a high competence value. Then finally we can find a bounding box containing the whale. Problem is that our expected location is like that, but it detects this part. Because this part is the most important key point for identifying whale. That is why it mentions this one. Most important attention area is like that. So system just see the wheel or head, then identify, classify this object as a dog and car. Write this exam. When you detect the whale, the key part of this image is like this. So if you just using the non-maximal suppression, I think you may find a bounding box like this. To compensate the side effect, the modern object detection algorithm use two parts. One is the image classification, so object recognition part. The other part is a regression model for predict correct region of the object. So in most modern approach, is combine two modules. One is CNN for classifying the image itself. The other part is a regression model to predict correct the bounding box. The people say that you can see this part. Can you imagine what it is? Only look at this part of the images. But you can recognize or also identify this one, the same one. But you can identify the object easily compared to the left side, because you can the imaging also recognize this object using the context over the other object around some object. So technically, we wanted to combine the conventional object detection and the context information. That is possible? I don't know yet. We try to combine the context informations around the object and the object itself. That many people say that is a context awareness based object detection. The concept is introduced and announced, but I don't know whether it is successfully applied or not. The last part, I introduced applications of object detection using the deep learning. That is the current project. First one is traffic analysis using the drones. The analysis traffic, so we capture the acquired PDFs of an intersection of a road in Korea. That is the acquired by the drone on the top sky. That is an intersection in Korean road. So we labeled each car as the Saturns, bus, and truck. So that is the result of our detected images. Our system cannot detect the car. The color is similar to the road. The resolution of the camera is too low, so it is not easy to detect correctly. Sometimes the classifying the truck as a Saturn, something like that. That is the demonstration videos. We applying our object detection algorithm to some analysis over the traffic in overload in Korea. So another example, right there. Another example of our current research is X-ray scanner. The leading global company in Korea, they usually operate the security checkers. I mean, to protect their some intellectual property or some business information. So they use the X-ray screener at the security checkpoint, like some immigration, the security centers on airport. But the detected object is different from some homeland security. In homeland security applications, the X-ray screener detects the gun or the blood sample, something like that. But in this applications, we needed to detect the USB memory stick or peripheral device or something like that to, the storage to protect the leak of information inside the company or the research institute. That is the example. So many people try to read the information using the mobile phone or some USB memory stick, something like that, inside the bag. So are there inside the bag using the X-ray scanner. That is our current the project. Okay, that is end of my presentations. Thank you.
Okay, Professor. Okay. Quite interesting in the X-ray one. I'm thinking if I have several handphone inside my bag, so the officer can see whether if I have, let's say, 5 phones in my bag. In Indonesia, it's a bit strict, Professor. For your information, we can only bring 2 or 3 phones, new phones, from overseas. If we go into Indonesia, or otherwise they will take that phones, and then they will fine us for certain money if they catch us if we bring, let's say, 3 phones, new phones in Indonesia.
Actually, it's the goal of this application is different from your ideas. Yeah, actually, we wanted to know try to steal the information of the company.
I see.
So some people store the important information into the USB memory stick or the mobile phone, and they hide inside the bag or others body and try to go out from their office.
I see.
But the mobile phone and the USB memory stick is not important. We just focus on the information inside the USB or the mobile phone.
Okay.
So some people, in most of Korean company, you can't enter or out with any USB memory stick or other digital storage. It's strictly prohibited because you can steal the information from the company.
I see. I
Yeah.
see. Understand. I understand.
Yeah,
Okay. I think I have one other question before I read the question from the floor. I have my personal question based on your presentation about object classification or detection. Is it possible now we talk about COVID-19? Is it possible to detect a person who wear masks properly within a crowd of people using your idea? And if possible, what are the challenges?
Actually, the face detection is possible because the eye is an important clue for identifying the face, but the recognition and identify the people using face, I think currently is impossible.
Mask.
Yeah. When you wear the mask, I can know that area is the human face or not. But sometimes I don't know who you are or who he is.
Okay.
So the identification and the detection needed to be distinguished.
I see.
Yeah.
Okay. Let me read the question from the floor, the participant. Wait, let me. Okay, wait. First, this is a question from Victoria University. How do we implement deep learning using CNN to classify an object into different types of categories? I mean, in a brief.
Yeah.
It's
okay.
a bit.
Yeah. I will show the example of the existing and conventional the object detection algorithm. The most popular object detection algorithm is YOLO and RCNN series. So this algorithm is consisting of two parts. One is generating the proposed region. I mean the bounding box. They think this bounding box include the object. Then each bounding box, the input to the CNN model to classify this bounding box is which the object is.
Okay.
Yeah. So the many object detection algorithm, the use of existing the model, such as for example, RetinaNet is widely used object detection architectures. That architecture consists over the object proposal and object recognition part. For object recognitions, that this model just use one of the existing CNN model, for example, ResNet 50 or AlexNet or some LUNAR, something like that. So you replace the existing CNN model plus the image classification. We just combine this object proposal part and the image classification part. For image classification part, you can use existing the CNN model.
Okay.
Okay.
Another question. Have you ever worked with data from satellite, Prof? Because this is there's a question he asked about how to deal with rapidly changing condition of cloud objects via satellite data. How to deal?
I think satellite data is a little bit different from the the conventional imaging. To analyze the satellite data set, if containing some large part of the earth or ground, I mean the road and buildings and something like that. In general, to analyze the satellite, the images, we use image segmentation or semantic segmentation approach instead of object detection itself. Because the object detection shape is varying, and some object is too small just to detect. So as far as I know, my colleague currently is focused on the image segmentation for the analyze the satellite imaging.
Oh, nice, very nice. Okay, another question is from Miss Rohana. How to evaluate overall object recognition? Because she said it needs more than one task. So do we train each task separately or not?
I'm sorry, I don't understand
the question.
the question.
I'm trying to, okay, let me reread the question. How to evaluate the overall object recognition? Is it like, okay, I think we skip that first question. We go to the second question. How do we train each task of object recognition separately if we do object recognition?
Actually, the image classification usually the user one model to classify several objects. I mean, one model can distinguishes car and dogs and the pedestrian.
Okay.
So we just input the bounding box to the CNN model, then it identify or recognize this part is a dog or cat or the car. So you need to design this output over the neural network, and you make us a train data set over the separate the classes. So you can train only one model to distinguish is car, pedestrians, dogs, animals, something like that. Yeah.
Only one.
Yeah, only one. We just cropped some part inside the image and classifying that image classifier model.
So is it the one that you shown the bounding box classification? You also train one by one.
Yes, right.
I see. Okay. Next question. There's another question. How to build a data set for object detection on X-ray?
X-ray imaging is a little bit similar to the okay, the object inside the X-ray is similar to the normal image. You can see that this one. Oh, sorry. As you can see, this one is an X-ray image in the X-ray screener. I think that is very similar to the normal RGB images, right?
Okay.
But if you try to use object detection for the X-ray image over in the field of medical, I think as a medical X-ray image is quite different from the DC application, because in medical applications, the image is the capture the human body. There is no exact separation area. So when you analyze the medical X-ray images, you need to consider the image segmentation instead of object detection. The image segmentation is more the useful the approach for the medical image analysis, because the object is defined as like that, separate and small, and it has a distinguishable the boundary. But in medical images, it is knowledge to separate the object from the background or other organization inside of human body. So generally, the people try to use image segmentation instead of object detection for the medical image analysis.
Okay, so we use image segmentation. Okay, I think last question from myself. I'm a bit curious about object detection using drone. What is the biggest challenge, Prof, to perform object detection using drone?
Most important thing is the quality of the image.
Okay.
So you need to mount the camera to the drone, and the drone bring the camera up to sky.
Okay.
So the weight or the dimension is limited, restricted, because if the heavy cameras, drone can bring the upside.
Okay.
So the quality of the image from the drone is not good.
I see.
Yeah. So
I mean, is it possible to change the camera of the drone to get a better image?
Yes, that is very helpful. But currently, in hours of the research, that is the best quality of the image from the.
I see. Okay then. Okay. I think the time is up, Prof. For this session. Thank you very much, Prof. Do you have any words for closing?
Yeah. Thank you for your attentions. It is an honor for me to attend this web seminar. And I'm very pleased to meet many the researchers and the students all around the world. I think we can use this opportunity to make many people. So please give her some information about the attendee, and
of course,
keep in
touch.
Yeah, keep in touch. Thank you.
Of course. Thank you, Prof. Thank you. Okay, so I think we will have a 30 minutes break before we continue to next session. I think how about Mr. Rian? You have any information?
No, actually, so we can start. We can break for 30 minutes. Yeah.
Okay, we have 30 minutes. For 30 minutes. Yeah, for break. Nice. We'll start at 1 past. Hey, this is 12. What time is it now? 11. Before
11.
30. I think 11 past 30. We will start.
Yes.
Okay. Okay. See you in the next session.
Informatika, salah satu jurusan favorit di Universitas Islam Indonesia. Jurusan Informatika memiliki sekitar 1.500 mahasiswa aktif. Jurusan Informatika Universitas Islam Indonesia berjuang mendidik para mahasiswanya agar dapat menjadi pemungkin solusi teknologi informasi dengan nilai-nilai keislaman. Jurusan Informatika Universitas Islam Indonesia memiliki 2 program studi Informatika Program Sarjana dan Program Studi Informatika Program Magister. Dengan kurikulum yang dikembangkan pada tahun 2020, mahasiswa Program Studi Informatika Program Sarjana tahun keempat bebas memilih 1 dari 5 penjaluran untuk menyelesaikan program sarjana: penelitian, magang, belajar di luar negeri, pengabdian masyarakat, atau perintisan bisnis. Aktif berkontribusi pada pengembangan disiplin keilmuan kekomputeran, jurusan Informatika Universitas Islam Indonesia memiliki pusat studi yang menjadi konsentrasi program magister: Informatika Medis, Sistem Informasi Enterprise, Forensika Digital, dan Sains Data, dengan 7 grup riset: Sistem Informasi, Sistem Siber, Informatika Medis, Informatika Teori dan Sistem Cerdas, Rekayasa Perangkat Lunak, Multimedia dan Visi Komputer, serta Sains Data. Jurusan Informatika bertekad untuk terus menjulangkan inovasi dan melebatkan manfaat dalam dunia IT. Pembelajaran di jurusan Informatika Universitas Islam Indonesia didukung dengan fasilitas yang memadai seperti laboratorium, akses internet cepat, dan ruang belajar yang nyaman, sehingga para mahasiswa dapat mengaktualisasi diri mereka secara maksimal. Jurusan Informatika Universitas Islam Indonesia juga aktif menyelenggarakan seminar nasional dan internasional. Di antaranya adalah Seminar Nasional Aplikasi Teknologi Informasi, Hacking and Digital Forensics Exposed, dan International Conference on Information Technology and Digital Application. Jurusan Informatika Universitas Islam Indonesia juga telah menjalin kerjasama dengan berbagai institusi luar negeri. Di antaranya adalah Raja Manggala University of Technology, Tanyaburi, Thailand, Youngsan University, South Korea, Nanjing Xiaozhuang University, China, University of the Cordilleras, Filipina, Tyler's University, Malaysia, serta beberapa institusi terkemuka lainnya. Jurusan Informatika juga telah bekerja sama dengan beberapa perusahaan IT seperti Tokopedia, Gameloft, Javan, Solusi 247, dan masih banyak lagi. Digital kini telah menjadi budaya. Jurusan Informatika Universitas Islam Indonesia siap untuk menjadi pionir digitalisasi dunia, memberi semangat kepada masyarakat dalam menyongsong dunia digital, dan mendorong lahirnya inovasi-inovasi teknologi yang solutif. We are IT Solution Enablers, Informatika UI.
Welcome back, everyone. Good afternoon to Dr. Julian. Are you there?
Yeah, yes. Yeah.
Okay. Let me introduce our final speaker for today, Dr. Julian Sibaroni. Okay, he is a lecturer and researcher at the Telkom University of Indonesia since 1999. He received his Ph.D. from Bandung Institute of Technology Indonesia, and his research interests include machine learning, natural language processing, text mining, and social media analysis. Several works on such areas have been internationally published. Okay, Doctor, you may now start the speech. You have 60 minutes on now.
Okay. Okay, thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Greeting, good day. Peace be to all of us. Hopefully we all in good condition and healthy. Thank you for the opportunity and time given to me. In this session, I would like to convey material about data science in paper relation and how applied AI in paper relation. Data science trend in recent time make this science interesting to observe. The growth of data on the internet, the more it attracts us to gain valuable knowledge and information in it. And data science is the right answer for this case. Data from several job sites like in this table show that data science job are currently in the high position among other fields. This why I choose the topic in this presentation. And for the case, I choose the paperless relation, where this topic is maybe is rarer in discussion with other researcher. The following is review of the material that I will convey. The first part is about data science, where in this part I will define about definition of data science, data scientist, and what skill that we need to become a data scientist. And the last is data science life cycle. And in second part, I will talk about data science in paper relation. There is definition about paper relation, information and knowledge obtained from paper relation. And the last is example and illustration, data science in paper relation. The first is, we will talk about definition about data science. In short, data science is science of data. But there are several researchers define about data science. And although data science seems to be trending recently, but actually scientists have defined data science since several decades ago. The first is definition by Naur in 1974. Data science was defined the science of dealing with data. Once they have been established, well, the relation of the data to what they represent is related to other field and science. Project et al. In 2015 defined that data science is the extraction of learning from substantial volume of information that are unorganized or unstructured, which is continuation of the field of information mining and perceptive investigation, and otherwise the data science is called by information disclosure and information mining. And the last definition is given by Longbing. Data science is new interdisciplinary field that synthesizes and build on statistics, informatics, computing, communication, management, and sociology to study data and its information. In order to transfer data to insight and decision by following data to knowledge to wisdom thinking and methodology. We can see from this graph that data science is intersection between some other knowledge or science. And what is data scientist? Data scientist, of course, is someone who work with data to solve a particular problem. Data scientists are responsible for collecting and analyzing data produced by a program or system. They develop algorithm and build model to produce valuable insight from trend in this data. And data scientists will then use this insight to solve problems within an organization. So we can see that data scientists is work depend on problem. Maybe they use some algorithm, maybe they create some classifier or etc. But the goal is to solve particular problem. What is skill to become a data scientist? Top skill for data scientist, there are 10 skills where divided into two groups. The first group is soft skill, including critical thinking, communication, problem solving, business mindset, and teamwork. And a second group is hard skill, including data preprocessing, statistics, data wrangling, machine learning, and AI, and data visualization. But in this presentation, I will focus more on discussing 5 skills in hard skill. The first skill is statistics and also mathematics skill. In other resource, we can find that not only statistics that need to solve problem in data science, we need mathematics skill too. There are areas that are important to study, namely statistics and probability. With statistics and probability, we can use for visualization of feature, data preprocessing, feature transformation, data imputation, dimensionality reduction, feature engineering model, model evaluation, etc. Multivariable calculus is extremely important for building a machine learning. We know in machine learning and AI skill, we need multivariate calculus to develop more good classifier or good model, etc. In linear algebra, is used in data preprocessing, data transformation, and model evaluation. And in optimization method, most machine learning algorithms perform predictive modeling by minimizing an objective function. How about data wrangling skill? In data wrangling skill, is knowing how to wrangle and clean data will enable you to derive critical insight from your data that would otherwise be hidden. And in data preprocessing skill, dealing with missing data, handling categorical data, encoding class label, feature transformation, and dimensionality reduction. Data preprocessing skill is related with the other skill like the statistics skill. The next is data visualization skill. We have to understand the essential component for good data visualization. This includes an understanding of data component, geometric component, mapping component, scale component, and label component. In data component, know what type of data. For the example is categorical data, discrete data, continuous data, and time series data. In geometric component, it's about what kind of visualization is suitable. For example, scatter plot, line graph, bar plot, histogram, etc. In mapping component, it's about decide X, Y variable. This is important then your data set is multidimensional. And in scale component, the example is linear scale or log scale. We can choose the best scale when we display the data. And the last in label component, this include things like X label, title, legend, font size to use, etc. This scale may seem simple, but it is very influential for someone in understanding and obtaining information in data more easily. The scale also closely related to statistical skill. Usually, someone with background in statistics will study about this more than other background. And then about basic machine learning skill. Understand the machine learning framework and algorithm, problem framing, data analysis, model building, testing, and evaluation. In super learning, in machine learning, it can be divided in 3 categories. The first is supervised learning. The second is supervised learning, but for discrete variable. The first for continuous variable. And the third is unsupervised learning. This is the example, what method in its group. For the example, in supervised learning, there is basic regression, multi-regression analysis, regularized regression. This technique or this method is based from statistics. In second group, supervised learning, discrete variable prediction. The example is logistic regression classifier, support vector machine classifier, nearest neighbor classifier, etc. There are so many classifiers that relation with this group. And the last for unsupervised learning, the example is Hamin clustering algorithm, hierarchical clustering method, density-based clustering method, etc. In addition to these 5 skills, there is basic skill that must be mastered in data science. The skill is coding, skill coding. Programming skills are essential in data science. Python and R are considered the two most popular programming languages in data science. We can see from this table, the most common data science language programming that use is like this: Python and R is the two top in position. And the next is data science life cycle. To understand how data science is implemented in solving a problem, let's look at the diagram. We can see there are four main processes in this diagram. The first is business understanding. The second is data acquisition and understanding. The third is modeling, and the fourth is deployment. The four process is have relation, and this is explanation for the business understanding. Because the data science is the problem is from the customer, we have to understand about business understanding. In business understanding, we have to specify the key variable that are to serve as the model target and whose related metric are used to determine the success of the project. And the second is identify the relevant data source that the business has access to or need to obtain. The second process is data acquisition and understanding. It related with data source, pipeline, environment, wrangling, exploration, and cleaning. In data acquisition and understanding, the target is produce a clean, high-quality data set whose relation to the target variable is understood. Look at the data set in appropriate analytic environment so you are ready to model. And develop a solution architecture of the data pipeline that refresh and score the data regularly. In modeling, feature engineering, we create data feature from the raw data to facilitate model training. This is usually the important thing, how to choose the appropriate feature to obtain the accurate result, accurate classification or accurate prediction. In model training, we find the model that answers the question most accurately by comparing their success matrix. And the last is determine if your model is suitable for production. In data science, we cannot only to choose one model as the solution. Usually, we have to compare many model, many classifier to obtain the best model or the best classifier. And after the best model or best classifier we get, then we continue by deployment. And the last process is deployment. We deploy model with a data pipeline to production like environment for final user acceptance. The decision for data science is customer, because customer give the problem to us. Data science is teamwork work. We can solve the data science individually. In customer acceptance, finalize project deliverable, confirm that the pipeline, the model, and their deployment in production environment satisfy the customer objective. Maybe this step is not in one step we can achieve the final, the satisfying the customer objective. Maybe we can the process is written to previous process. We improve the model, or we improve the feature that in this process, and we deployment again until the customer satisfy the objective. Okay, this is about data science in paper relation. In this presentation, problem in public relation will be problem to be solved using data science. The number of scientific paper produced each year is interesting to observe. For example, in this graph, in this diagram, we can see that in 2018, the number of paper is more than 2 million paper, where the China production of paper in China is more than 500,000. This is about 20% in all the world. And in right graph, we can see that the increasing trend of paper production is increasing subtly. So in the next year or some next year, the production of paper will more than that in this year. This is simple illustration of paper relation. Let's see, every node in this graph denote as paper, and the paper and other paper have relation. A relationship that occur between one scientific paper and other scientific paper is definition of paper relation. But how is this relation formed? The first is from citation. We know from its scientific paper, it always have reference. It always citation inside. From this citation, we can make a relation between paper. But we can also find what the relation is formed. Behind the citation, actually there are several things that make up this paper relation. For the example is content similarity. We know in every scientific paper there must be content that similar. From that similarity, we can build a relation between one paper with another paper. The other thing is topic similarity or author or publisher. Maybe we can make a relation with paper that created by the same author, for the example, or we can make the relation paper that have the same publisher, or we can make correlation that between one paper with another paper based on topic similarity. The question is, what information and knowledge can obtain from paper relation? This is the core of data science, I think. When the problem is paper relation like this, we have to know what the information and knowledge that can be obtained from paper relation. This is some example what the information and knowledge that we can obtain from this paper relation. For the example, and the first is information about group of researchers in a particular research area. The second, history of research paper in particular field. The third is information about research field and a collection of related scientific paper. The fourth, information about trending research topic. 5, information about the state of the art in the various specific research field. 6, information on tool, data, method, and so on, commonly used in certain research field. 7, information about research weakness in particular field. But all the information or knowledge presented here, of course, depend on what consumer want. For the example, we have the customer that need information about maybe tool, data, method, and so on, commonly used in certain research. So the focus of data science to implement in the case is information on tool, data, method, not the other information. So the point is all the information that we process in using data science is depend on customer want. And for the illustration of example that I want to give in this presentation is for the example is number one case. Information about group of researchers in a particular research area. How to use data science to solve this problem. AI and machine learning play an important role. For the example, this is the step that we can do to solve this problem, number one problem. The first is author title information extraction from each scientific paper. The key is information extraction method. The second is title classification in one particular research field. The third is author classification in one or more research field. this called by multi-class classification in text mining. The third process is based on process 2. And the last process, the last step is visualization. Visualization. This may seem simple, but maybe we can see the detail as simple like this or not. But the main process, I think everyone is agree that this process is not complex. It's look simple process. This is example of information extraction method that can be done for this case. In information extraction method, this is the several steps that we can do. Like the first is extracted component. We can extract, we know the data set is one research paper. In each research paper, scientific paper, we have to extract, for the example, abstract, image, table, and etc. Our system have to ability to extract this component. This model is this method is called as PSG method. Of course, beside this method, there are several other methods to information extraction. But the most method is method based on rule-based method. After we can extract for its component, we can extract title and author, because the focus of information extraction in first step is title and author information. But we have to know that each paper sometimes have different template. Of course, it require different rule to handling this. Okay, after we can extract the title and author, we can continue with the next step. The next step is feature title classification. That I mean, this in title classification is we classify a title into one class. For the example, we classify one title to information system, maybe, or informatics, or computer science, telecommunication, and etc. Of course, this process need called as supervised learning. So we need to define class label firstly by user. Input of this system is title of paper. We make some pre-processing here. In pre-processing, after pre-processing, we continue by feature identification. There is some process that in pre-processing step. For the example is like stemming, stopwatch removal, and etc. The next process is feature identification. there are several basic features that can be used in tag classification. For the example is BOW, back of word, or generally n-gram. This is most tag feature that usually used in tag classification. The next process is feature extraction. We extract feature that we identify in this process. Beside the common feature like n-gram, there are other feature like NLP feature, pattern-based feature, or new feature that maybe that we propose that we use to get the more accurate result. In feature extraction, we extract the feature that we define in this process, and continue by feature weighting and selection. In feature weighting and selection, this process is used to create weight value of the n-gram feature, usually back of word feature of n-gram feature. Usually that the technique, that method give more accurate result. There are several features or term weighting method. For the example is TF-IDF and all variant, TF-IGM, TF-RF, TF-IGM, and etc. Behind the TF-IDF, there is other weighting method too, like the chi-square method, information gain, W-min, and etc. After this process is we continue by learning model. Model will learn to get the optimal model based on data. In data science process, we should use not only one classifier or one model. We have to use some or many classifier or many model in this process, because the main goal is to obtain the best model or the best classifier model. And the final step is using the classifier, using the best classifier to make prediction. Usually the data will be divided into data training and data prediction. Data prediction have a size more bigger than data training, because in data training there is a manual process like labeling, and that need time. We can use the huge data in labeling process, because the labeling process is using manually. And this is an overview of feature selection. In feature selection, you can see from this diagram, feature selection is process before the learning model. We back to this process again. This is some illustration about process in feature selection. In this feature selection, it very correlated with feature weighting. After a weight of each term is calculated, we will obtain the score of each term, and we can sort the term score, and we can choose, for the example, the top 10%, the top 20% feature, the top 30% feature. From the sorted term, then we can make a prediction like the previous step. We can continue by learning model. And finally, process is author classification and visualization. For the example, in this case, this is the illustration about the number of publication of its author. For example, there are 5 authors, A, B, C, D, E, and this is the field that we want to. This is the class label in our data. For the example, the author A have 50 publications in computation, data analysis, software engineering, theoretical computation, information system, etc. And from this table is we obtain from the previous step in step number 2. From the table, we can make author classification. For the example, we can use the multi-label classification. The rule is get top 2 class. For example, for computation and data analysis, the member of author is A and C, because A have the top 2 of publication is in computational data analysis and software engineering, and the C author have sorry, there's a mistake in this illustration. It should be D, not C. A, E, then N, and D. And in software engineering, the example is there are 3 authors, A, B, and D, because the A, B, and D have the many publications in this field. And in theoretical computer science is C. There's only C, because only author C that have many publications in this field. Okay, this is illustration of how data science is implemented in paper relation case for number 1 case. Thank you for your attention.
Okay, thank you, Dr. Julian, for your presentation. Quite interesting. You give us the overview about data science and data scientists, and also the application of data science. I think we still have a lot of time. Let me read the question from the participant. First question is, what is the important role of a data scientist for a company? This is from Mr. Fiskar from Halu Oleo University.
Important role for?
important role
yes.
of a data scientist for a company.
For company, okay. Okay, I answer directly or
Yes,
collect on?
yes, you may now answer.
Okay, okay. Important role of data science. Okay, like our my presentation previously, that data scientist is work based on customer problem. For the example, the customer is the company. Of course, important rule for data scientists for company is he have to know the basic problem of the company, what the company want. But usually maybe the company or the customer sometimes is can give what they want about the data. Sometimes it often happen. If the case is happen, then data scientists have to maybe give preview previous solution, maybe give like a solution from his maybe from the previous case that he have handled. He can give the example how to handle data like this. But if the company give the clearly what they want, maybe like the case that I give in this example. For the example, he gave he want the research history of research in paper like this example. We can focus the problem that they want. I think that is my answer.
Instead of developing our own application, Doctor, is there any specific application or software that data scientists normally use?
Okay. Any specific software
Or application?
Application, okay.
Mm-mm.
That usually use, okay. Okay. That I know, yeah, like the I present in the skill that data scientists have. I think for the application is maybe there is application that usually used, but it only good for the specific company and not free. Not we can use free. We can use free in that application. That's why the company usually need need staff or employee that have Python or R skill or other language programming skill. That I know the application that we can use, like maybe like Microsoft Office or Word or something else. I think there is not free application that we can use like that. I think every company is still develop the suitable application for the problem in their company.
So you mean it is
specific-
better to develop on our own?
Yes, yes.
I see. Okay, okay, okay. Next question is this is from Mulian Shah Rasdakim. In title classification, manual labeling of dataset would take a lot of time. Is there any way to make it easier or faster and more accurate?
Okay. Yeah. In every task of text classification in supervised learning model, there is always manual labeling. But for the faster method that I know, there is semi-manual labeling. For the example, we have 1 million data for the example. From 1 million data, we can divide maybe 1,000 in manual labeling, and the rest is labeling by automatic labeling. One technique that used in this case is we use method like can your neighbor. After 1,000 we have manual labeling. The rest about 900 and 1,000 data, we can manually, we can automatically labeling by using method like KNN method for the example. And in some paper that show that the model that obtained from semi-automatic labeling like this give better accuracy that we only use 5,000 data for model learning for the example. So as far as using semi-automatic class labeling.
So for you suggest to use semi-automatic.
Yes.
Semi-automatic. Okay. Okay. I have my own question based on your presentation. If I'm mistaken, you just you mentioned about detecting research weakness.
Okay, detecting
research weakness for a particular field using in paper relation. So, could you please explain more about this and how to do that and so on?
Okay. Yes. Maybe this is the number
4. If a second.
Okay.
4. I'm not really sure.
Number 7.
Yeah. Okay. 7. Yeah. Okay.
Number 7. Okay. Okay. How to get the information of research weakness? Yes, I have doing research about criticize detection in paper relation. So the first step that we can do is doing criticize or weakness paper relation. We can use classification method to classify center in paper relation as criticized or not. This is the first step. After we get information about classification about weakness and not weakness sentence in paper relation, then we can use another technique, maybe like summarization or clustering method. Yeah. We can use or maybe information extraction. We can extract, for the example, what is the for its paper who the author for the paper, for the example, and we can extract to the weakness of uh, the paper, and who criticized the weakness or limitation. Like it look simple, but actually, if we do that research, there's more challenge that we can meet in our research. Yeah. So the point is we can classification in sentence level, in not in paper level, but in level and center level. We have to manually make class labeling. This paper is there is weak sentence or not. We have to make class labeling like that. It need more time to finish that.
Yeah, I think because it's not always that a paper they mention explicitly or clearly about its weaknesses.
Okay.
Right? That makes your idea more interesting to me.
Yes.
Especially on how to determine the what you call it the terminology of weakness.
Okay.
How to determine, okay, this word can be said weakness, this word is not weakness.
Yes, there is research about like that, about paper identification classification by Wang in 2012. He defined what is defined as criticize, for the example. Criticize when the author see or there is a statement from the author that direct fetus or something like that in other research. So the focus is we can focus only for citation sentence. So the first step is extract citation only, citation sentence only. From this citation sentence only, we can see deeply where is the namely weakness sentence or not, compare sentence or not. There is some classification about sentence in by Wang in 2012. Yeah. Compare, criticize, extend, etc.
Okay. One more thing. This is quite general. I think this is quite general in data science knowledge. How do we balance? How do we balance data collection and privacy? I think this is a quite a hot issue in data science. What do you think about that?
Okay, about data privacy.
Data collection and privacy
and privacy. Okay.
Yeah.
In my opinion, I think when yes, in for the example in classification method, yeah, we have to see its data manually. For its data, we have to see manually, and if there is privacy data that I think that if we or when or like this, when we publish a research paper that contain data, yeah, we have to see where is the privacy data or not. But usually in paper publication or in data science, we are not focused to individual object. Yeah, I think the conclusion that we give is for general. So when we crawling the data from the internet and we get the data that we think that is privacy data, the ethic of researcher, of course, is not publish privacy data like that. We can focus in general result from this research that we do. Or if we give the data for the company or other consumer, I think the customer is not focused, but individual like that. And if it related to privacy data like that, we can hide the identity about the data, so customer or someone else can see the data and come from who, like that, I think.
Okay. I a bit understand about this. Okay. I think one more question. This is the last question from she or he said from Malaysia. He said he is an accountant, and he asked that the question is how learning AI or machine learning or data science could be a benefit for him or her as an accountant.
As accountant.
I mean, how data science can benefit him.
Okay. His profession is accountant. Yeah.
Accountant.
Oh, accountant. Oh, accountant. Okay. What is the benefit? Okay. I think the benefit that we obtain from this process is there's many benefits. For the example, in maybe in this process, what is benefit? Okay, the benefit of like I say before that in my previous presentation that data science is doing by, I think, by several team, maybe not only one person. I think is impossible because there are many process that doing in data science, yeah, like this, yeah. Maybe in business understanding. There is a team from with background economy to know what the business of the consumer, and what the benefit is when using machine learning or AI in this process. We can make model that accurate from huge or from a big data. If use only namely traditional method, maybe like decision tree, but by person, maybe like a content or economic can have something rule to handle about maybe I give example like in accounting like what namely there is maybe in bank report, how to know the bank report is there is what it, there is it's true or not, maybe we have the case, we have to determine from 1 million bank report where is the correct report or where is not the correct report. We can calculate if we have 1 million report to handle it. How many time that we have to spend to solve this problem? When using data science approach, we can only maybe using about 1,000 report to make model, classifier model with good accuracy, and then by using that model, we can classify rest of report data as correct or not. I think it's more efficient that we have to use manually approach to handle this problem. I think the benefit is like that. Maybe the accuracy that we get in the model is not 100%, but maybe about 80% or 90% accurate. But by using 90% accuracy, we can solve 1 million report in short time. That compare then we use manually method. I think this is my answer. Thank you.
Okay, so you mean there's a lot of efficient way to do accounting process, and it can be supported by data science.
Yeah.
Okay, I think the time is up for this session. Thank you, Dr. Julian, for your time.
You're welcome.
Any closing words for us?
Yes, data science is maybe in Indonesia is not what the name it's not familiar, but I think when we see the future of data science in or when we see the data science in other country, I think to be knowing about data science or to be a data scientist is will be potential for us to in the future. Actually, for the student that maybe in the there is still study in this university. Yeah. I think this is a good knowledge that we have to know, and maybe in future many company in Indonesia will have will open a job about data science. I think this is closing speak from me. Thank you.
Okay, thank you. And that is all our today's webinar. To all participants, please do the exit ticket before leaving this webinar. And see you in the next event. Mr. Rian will now say something about the price.
Okay. Okay. Sorry, there's an error. Okay. Okay. Let me change the screen. Wait for a second. Okay. So this is the lucky participant for this event. So there's Abdul Aziz Muhammad, Armin Matluti, Edi Mulyanto, and Rohana Pri. And we will contact you as soon as possible for the prize. And this is the exit ticket. So please, every participants fulfill this form. So it will be closed in 60 minutes. So the Zoom will be open, I think, only 5 minutes, but you can access the code, the URL in the YouTube stream. So if you forget the link, you can access it in YouTube stream. And then sorry, it's a lot of people joining. Okay, so please fill the form in the exit ticket, and all slides is available in s.id/WSI. It's all slides from the first webinar. And then I think that's it. Thank you very much for all the speakers and all participants who have joined this event. And this is the last webinar series. So this is the fourth series. You can get, if you want to know the all series before, you can see you can watch in the YouTube channel. There's a recorded version of the webinar, the previous webinar. And then, okay, thank you very much for all. You can please fill the exit ticket. Thank you. I will be close this event, and so I'm on behalf of Department of Informatics. I want to apologize if there's something that something not good for you in this event. So thank you. Assalamualaikum warahmatullahi wabarakatuh.